So in this video, we'll be solving question number 3 of IBDP May 2025 Physics question paper 1B. So this is a question which most of the student found problematic. So let us solve it. So just before solving, let me just give you some idea of it. So this setup is called Helmholtz coil setup. So using this we can find out the horizontal components of Earth's magnetic field. So before we start this question, let me just quickly give you a brief overview of Earth's magnetic field. So our Earth behaves like a magnet. A huge bar magnet is inside its core. Okay, so if this is the axis of the Earth, the magnet is somewhat like this. That means the magnetic axis is not as that of the geographical axis of the Earth. So this is our magnet. Okay, and this is the south pole of the magnet, and this is the north pole of Earth's magnet. So hence the magnetic field lines go like this. Okay, don't get confused with the north. Yes, this is a north, this is a geographical north, not the magnetic north. Okay, and this is a geographical south, and our magnetic north is near the geographical south, and our magnetic south is near the geographical north. So basically, because Earth behaves like there's a because of the iron core, the Earth behaves like Earth have a magnetic field whose south pole is towards the north of the geographical north, basically. So this is why Earth also behaves like a magnet, and we want to find out the horizontal component of the Earth's magnetic field. So now the horizontal component is the BH is denoted by BH. This is the horizontal component to the resultant magnetic field. Okay, so we'll talk about it. Then how do we do it? So let us solve this question. So to cut the long story short, our Earth also has a magnetic field, and we are finding out the horizontal component of that magnetic field using this setup. Okay, so the setup looks like this. We have two coils. This you can see coil 1, coil 2. Of course, these are current carrying coils. So a current carrying coil induces magnetic field, right? And then you are using another magnet in form of magnetic needle over here in between them. So if a current will pass through these coils, what will happen? The coil will induce a magnetic field. So let us quickly talk about the direction of that magnetic field over here. So if we see that the arrows are in this direction, right? So if I'm using my right hand thumb rule, if I curl my fingers in the direction of current, right, the direction of current is like this. If I curl my fingers in this direction, sorry, I'm very bad at drawing, right? So I would see my thumb is pointing out in this direction if I look from this side, and if I look from the other side, so it will be in the opposite direction. So basically this axis, this is the direction of the direction of magnetic field generated by the coil. Okay, cool. So once the current gets we set up a current in it, the coil produces a magnetic field and that magnetic field's direction is along the axis. Okay, cool. Now let us read the question. So the student have to decide on the horizontal separation of two coils. Their choices are separations of 2r, r and 0.5r. So they are talking about this distance. So you can see over here there is some separation between both the coils, right? The distance between both the coils. So the student has to decide what the separation he has to take. Three options are r, 0.5r, and the third option is 2r. So now the question says which of the separation students should choose, and the information given to you is the graph. So if you look at the graph, these are the three graphs for three different separation. So this is the graph between magnetic field due to coils and the position. So this is the graph for 0.5r, this is the graph for r, and this is the graph for 2r. Okay, so if you look at the graph, in between the coils, if you see, if you see in between the coils here, if you see magnetic field is not uniform. Here it is uniform just very for a very short position, and here this separation r is giving you the most uniform magnetic field. So I'm gonna go with the most uniform magnetic field, right? So that it doesn't it is the easiest for me to this is the easiest way to find the horizontal component, right? So the answer, the question says state and explain. So there are two command terms, state and explain. So you have to write that you're going to choose the separation r, and then you have to explain why also. So I'm going to write I'm going to go with the separation r. And why? Because it gives the most uniform magnetic field between the coils. That is important. Between the coils. Okay, we're done with this. Now next question is, explain why the student place axis xx dash of the coil in the east west direction. Why the axis was taken like this? So that's the question, right? So why is this taken in the east west direction? So now to answer this question, okay, so we know the direction of earth's horizontal component is this. And if I keep, because we know that the magnetic field induced by the coil, the direction of that is always along the axis. And if I do that, the BC is the magnetic field because of the coils. I'm writing B coil. Okay, both are going to be at 90 degree, and at 90 degree the maximum possible deflection will take place, right? So that's a 2 mark question and they're asking explain, so you have to write both the points. So um, the first point is, if we do so, BH will be perpendicular to BC, or BH and BC would be normal to each other, and this setup, and in this case it gives the maximum possible deflection of the magnet, hence maximum, so the angle will be significant, and so that we can measure easily possible deflection of the magnet. Cool. Now talking about the C part. So the deflection of the magnet is shown. Of course, now you set up a current. Now there is a deflection in the magnet. Now the magnet is in this direction, you can see, and the magnet comes to rest when it makes an angle of 24 degrees. That means exactly at 24 degrees, all forces are getting balanced, right? So we have two magnetic fields over here. One is this BC and the other one is this BH. This is what we have to find out. They're asking using okay, determine using the graphs, BH graphs in this, of course. So from here, if I use trigonometry, can I write 10 24 equals BH over BC, because I can redraw BH somewhere over here, right? So this can be written, right? So from here, BH is nothing but BC 10 24 degrees. Now the task is to find out BC, and for that they have given you the hint using the graphs, right? So you're gonna take the value of the magnetic field because of coil from the graph. So you have to come back to this question and see, you chose which separation? You chose the separation R, right? Right, so you have to now take the value of BC. So from here, BC is this point. So if I read it, it is somewhere around 7.5, right? And this is, do not forget to look at the axis, is 10 to the power negative 5 Tesla. So 7.5 times 10 to the power negative 5 Tesla. So this is the value I'm gonna take. And let us suppose one of the student chose this graph in this question part A, and it chooses one of the value from here, so you would get ECF mark if ECF is allowed. Okay, now the correct thing is the separation R, and when we are taking separation R, the magnetic field because of the coil is 7.5 times 10 to the power negative 5 Tesla. So I'm going to use it here. Okay, so from here, BH is going to be nothing but 7.5 times 10 to the power, 1 second, sorry, I forgot, 10 to the power negative 5 Tesla into 10 24 degrees. And once I solve it, I get somewhere around 3.3 times 10 to the power negative 5 Tesla. So this is the value of BH. And with that, we are done with this question paper. That was the last question. So if you have done so, you would have got 2 plus 2 4 6 marks. Okay, I hope you understood what we did in this question. So see you in the next video. Bye bye, have a good day.